Hello, Flame community. This is Jeff Kyle with the Flame Learning Channel. The Flame 2026 release brings Linux users the machine learning Upscale, which leverages machine learning to significantly increase the resolution and detail of footage in very little time. In this video, we'll be covering where to find the machine learning Upscale and how to use it on your next project. As of this recording, the machine learning Upscale is only available to Rocky Linux users. We can access it either in Media Export under the Resolution section, or inside of Batch using either the Resize node or in the Render or Write nodes under the Destination section. While this feature is a function of resize, it's not available in the resize timeline effects, since the destination of a resize timeline effects is controlled by the resolution of the sequence. And note that when accessing machine learning Upscale via Media Export, we can only use foreground rendering. Taking a look at the controls here in Batch's Resize node, the Machine Learning Upscale is accessed via the Destination section, setting it to Machine Learning Upscale, where we then have access to the three models: double, triple, and quadruple. Similar to the other machine learning workflows, we have a cache option for Linux users, but it's a little different in that when GPU is enabled, it's always on, and when CPU is enabled, it's always off. With GPU enabled and with the appropriate graphics card, you can take advantage of NVIDIA's Tensor Cores to help significantly reduce render times for clips of the same resolution by not having to reinitialize the model, since it would only need to be cached once per session per resolution. Using the GPU is certainly faster than using the CPU, but it's only optimized for resolutions of 1920 by 1080 or lower. Working with larger frame sizes is possible, but takes considerably longer since not only is it a larger size, but it also uses the slower CPU processing. Heading over to the Flame Preferences under the User tab and the Tools and Timeline Effects tab, we have this Machine Learning Upscale section, giving us options similar to the Machine Learning Morph, but in this case, they're geared towards batch. We have the option of automatically switching to a linear resize filter and not use the Machine Learning Upscale when we're scrubbing or playing footage, or to ensure no such swapping happens during playback or scrubbing. Now let's take a look at the machine learning Upscale in some real-world examples. In this first example, I have a shot of a building with a street sign and some visible text. The source is 4K, but I've artificially lowered the resolution down to 960 by 540 so we can use the machine learning Upscale with the quadruple model and see how it holds up to the source. This first resize node is scaling the footage down to half HD and repositioning it just a bit. I'll pull out a fresh resize node, connect it to my footage, and first I'll look at the front of the resize with F1 so I don't initiate the engine cache before I'm ready. Then I'll switch it to Machine Learning Upscale, change the model to quadruple, and hit F4 to see the result. The ML engine cache initializes, thinks for just a bit, and before you know it, we have our result. If I compare the result of this machine learning Upscale to the result of a regular resize node scaling that 960 by 540 resize up to 4K using the Lanczos filter mode, we can see there's quite the quality difference, most visible here in the street signs. When I zoom in close, you can see that some of the letters do have artifacting with the machine learning result, but this is a bit of an extreme example where we can make out every letter, and if we look at what a normal resize gives us, it's quite blurry to the point where the text is almost unreadable. I have this third resize node here set to take the original 4K source and placing it in position based on the resize I did, so we can compare both results to the original source, and the machine learning holds up quite well. Here's the original source, the machine learning Upscale, and the Lanczos resize. I have one other example here focusing on more general details with this very detailed shot of an elephant. We won't do any cropping for this one, but I still have a resize node set to the scaling preset quarter just to simulate this footage being a little lower resolution than it actually is. Otherwise, we'll do the same operation. I'll take out a fresh resize node, attach it to our half HD footage, look at the front, set the destination to Machine Learning Upscale, set it to quadruple, and look at the result. Since I already cached my model for this resolution, the result is almost instant. I can see right away the intricate details are nicely brought back, and we can take a look at how the Machine Learning Upscale compares to the regular Lanczos. Panning around the image, we can see how it holds up to the non-machine learning result, and it's clear we're getting quite a bit more detail across the board. If I compare it to the original, of course it's never going to be better than the real thing, but it's pretty impressive how close it gets. Hopefully this gives you some inspiration for how you might end up using the new machine learning upscale the next time you have to deal with a push-in that's just a little too much, or if you need just a bit more resolution out of some source footage. If you like these videos and you're finding them helpful, please subscribe to the Flame Learning channel and click the bell to stay notified about new content. Feel free to comment any questions or suggestions below. Until next time, thanks a bunch for watching.